I'm going to now introduce an individual who will introduce the next moderator. And it's my pleasure to introduce Dr. Mae Jemison, who's a member of the National Academy of Medicine and a Texas resident. She was a mission specialist astronaut on the Endeavour mission STS-47, Space Lab J, which means that it was a space laboratory flight, but it was funded and organized by Japan in one of their early entries into microgravity research. She performed experiments in material science, life sciences, and human adaptation to weightlessness. She now leads the 100-Year Starship. It's a global initiative seed-funded program through a competitive grant from DARPA to ensure the capabilities for human travel to another star within the next 100 years while transforming life on Earth. So with that, let me introduce Dr. Jemison, who will introduce our next moderator. Okay.
Thank you very much, Bonnie, and it's really a pleasure to be here and have an opportunity to just say 2 words about the incredible work that goes on in space exploration. Mr. Lightfoot mentioned about the fact that it's inspiration that we're really dealing with, and I think that that's what's really important for us to take a second and recognize that public engagement is what's going to move us forward, and to think about why did we want to be involved with space exploration. For me, it was when I was a little kid. I just looked up at the sky. You talked about aviation and aerospace. We just look up, and what does that do to us? That connects us to the world all around us, as it connects us to other people, and it connects us to 1,000 years before when our ancestors looked up at the sky, wondered what they were, and then started to chart the movement of these lights. And we're building up on that, so it's very much a part of who we are as humans. And that exploration has so many benefits here on Earth, and we talk about it, but we need to engage the public in it. And so what I would ask is for us to always remember that if we have the public commitment, if some kind of way we engage students, if we engage people around the world, that we will be able to continue to explore and do those incredible things that benefit life on Earth and also make us better people. So tonight, even though it may be cloudy, look up. Tomorrow, look up at the sky and think about what the world has to offer us and how we can help. What I want to introduce, which is going to be a really exciting panel, is going to be led by Dr. Robert Metcalfe. And this panel is called Leaders of Aerospace Research in Texas. Dr. Robert Metcalfe is a professor of innovation at the University of Austin at Texas. University of Texas at Austin. Sometimes they think it's the other way, but that's okay. No harm into the A&M folks. Professor of Innovation at the University of Texas at Austin. He joined UT Austin in January 2011. Dr. Metcalfe is well known in the world of technology, having invented today's local area networking standard, the Ethernet. And this was while he was working at Xerox and Palo Alto Research Center in the 1970s. In 1979, he founded 3Com Corporation, and Dr. Metcalfe's research areas have included computer operating systems and networks, and his current research interest is entrepreneurial technological innovation and how to bring that to scale. He was inducted into the National Academy of Engineering in 1997. He is also a member of the National Inventors Hall of Fame, and he earned a National Medal of Technology award as well. Dr. Metcalfe.
Thank you very much. I'd like the panel to join me on stage, if you would. Dr. Dunbar reminds me frequently that aerospace is not just research. It's an industry. But this panel is about research. So we are lucky to have 6 leaders in research, and we're going to ask them all to opine about Texas aerospace research and its opportunities and challenges. And we are so lucky to have this group. It's embarrassing about how little time we're going to give them. 5 minutes each, and you all have an opportunity to ask questions for about 3 minutes after each set of comments. So please be ready. And I'd like to begin by introducing Dr. David Daniel, who's a civil engineer, a champion of research universities, and a deputy chancellor of the University of Texas. Okay. Oh, sorry.
Well, thanks, Bob, and thank you all. UT system institutions have two with aerospace engineering programs. The University of Texas at Arlington with Arian Armanios as the department head, and UT Austin with Noel Clemens as the department head. These are very active, vibrant programs. To NASA, I would say, don't worry about young people being interested in aerospace. Boy, are they interested. We have over 1,000 undergraduates at these two institutions majoring in aerospace engineering, and 350 graduate students majoring. And the job market is strong. Most of the graduates from both of these programs stay in Texas, as it turns out. And I think so many young people are attracted to the field because the job market is strong. Did I mention that? And the work is interesting and challenging. And as typically the case at successful academic institutions, programs tend to develop a flavor which bridges off capabilities and other strengths of the university. So at UT Arlington, for example, a key focus area is composite materials and the behavior of these high-strength, low-weight composites. They actually have and are using computer-aided tomography to look at the microstructure. Imagine a super strong microscope and a CAT scan with very high-speed photography to document the failure modes. And they're taking digital imagery at a rate of 10 million frames a second. 10 million frames a second at very micro scale. Some amazing work on the materials we're going to need to go to Mars and operate at super high speeds. UT Arlington is also working diligently to develop a high temperature hypersonic wind tunnel. And I think back to my undergraduate days and just am amazed at this. They're talking about temperatures of 3,000 degrees Celsius and wind speeds of Mach 4. I was talking to the Vice President of Research at the reception last night at Arlington. This is going to be interesting, Dwayne, to get that up and running and not blow anything up. They're also working on O2 recovery from CO2. If we go to Mars, we're going to need to ship as little oxygen up there as possible and recover as much as we can. UT Austin's program has a very entrepreneurial flavor. They're focusing deeply on robotics in space, autonomy, robotics, artificial intelligence to operate those systems is what students are working on rather than traditional guidance and navigation algorithms and programs. They're making use of the supercomputer Stampede 2. Tinsley Oden's built a tremendous team at UT Austin in computational science, and the ability to bridge off that capability and use enormous computational capability is very much an area of emphasis for them. Not surprising in Austin, there's tremendous interest in entrepreneurship. Uber, Elevate, the Jetson taxis. This is actually a most exciting area for students who not only want to get a degree, they want to change the world. And I think this is one of the things that's attracting so many bright young people to the field. They're working on high-flying unmanned vehicles. These are vehicles that would be solar-powered, fly at 60,000 feet, and essentially replace several hundred cell phone towers. And the idea that you could put a vehicle up there for a month and replace many cell phone towers and operate in very remote areas is appealing and is exciting. And of course, NASA efforts at Mars is very much on the minds of the faculty and students at UT Austin, and these areas of robotics and autonomy are really important to them. So I'd summarize our academic institutions as saying that the programs are healthy with strong student interest. What perhaps is surprising is one of the faculty members I talked to recently said, one of the concerns is the name aerospace undersells the breadth of the technology development in this field. And they wish they could find a better name because high school students have a picture of aerospace that in some cases might be limited to lift, weight, thrust, and drag. But it's so much more than that these days, like almost all areas of engineering. So quite exciting work going on in this discipline. I wish I were young again. It would be a great field to go into. Thanks, and are we going to take questions now, Bob, or you want to wait till the end? How do you want to do
Let's
this?
take questions now, and I have one for you.
Yeah.
You know, you've worked very hard at advancing research universities. I wonder if you could give us a minute or so on how research universities are evolving at this time.
I think our research universities are challenged these days. They're challenged by funding, of course. Research is not an inexpensive enterprise. Texas, for example, really has only one, now maybe to some extent two with SMU, but one great private research university, Rice University. Why? Because it's really, really expensive to develop a major research university. But University of Houston has made great strides. Texas Tech has made great strides. UT Dallas, UT Arlington, and other institutions are moving ahead. But I think it's a challenge. And I think research is not necessarily at the front of the mind of the average person, particularly when they think of universities. But for business people and folks like NASA who understand the challenges of the world and recognize that the high ground of discovery and innovation is where the future economies are going to thrive, we'll make those investments. So I think perhaps educating the public about the importance of research might be challenge number one in my mind.
Questions? Right over here, please.
Richard Gibbs, Baylor College of Medicine. I have a related question, which is, as we anticipate much more involvement of private industry in space exploration, all aspects of space exploration, how will this impact the balance between basic research and applied research in your environment? In other words, is that going to suck things out of what you do now?
No, I don't think it's going to suck things out of what we do now, and I don't think basic versus applied is a unique challenge for aerospace compared to any other field. I would just say this. The great universities of America and the world have a balance between basic research and applied research, and it's not at all as if it's one or the other. In fact, the richness of ecosystems of basic discovery and applied discovery and even technology transfer, when done well, is in fact relatively seamless. So I don't see that as a challenge. I see the challenge being essentially for public institutions. The demands for funds are great. The thirst for support of our institutions is great. And I think in the end, if we can add value to the private sector, and the private sector can hire students with internships, provide scholarship support, and so forth, I think we have great reason to be successful. I've always used the following mantra, and I think it works well in Texas, and that is the most successful enterprises tend to work on globally significant problems of great interest to local employers and local governments, because you need support, and if you can get support in Texas and from our local environments to work on globally significant problems, then I think you can get there in terms of basic and applied research.
Well, thank you very much.
Thank you.
Moving right along, let me introduce Adam Hamilton of the Southwest Research Institute, an aerospace engineer, I read.
Yes, I am. Thank you, Bob, very much. And also thank you to Tamist for the invitation to be here today. It's a great honor to be here and to represent Southwest Research Institute. Now, many of you may not have heard of the Institute before, but we are based in San Antonio, Texas, but we have offices in other locations as well. But we are an independent, applied, back to that question about applied versus basic research, we are an applied research and development organization that is in its 71st year. So deep roots, but we're still on the very cutting edge of a lot of R&D and technology development that's happening in the aerospace and space sectors. We have a very broad technical base and a reasonable size of externally funded research that happens in excess of $500 million a year, but it's in many different fields. We'd like to say, since I've been there, this is my 4th year now, and I am a structural dynamicist from Aerospace Engineering Department at UT Austin, we say deep sea to deep space because literally the portfolio has covered everything from pressure vessels for the Alvin submarine to astronomy, where we're really looking at deep space, but also very exciting missions like New Horizons that I'll talk about momentarily. So in the aerospace area, I had to put structures first. We do a lot of structural dynamics work, looking at all different types of lifetime extension for airframes, propellant dynamics, fuels and lubricants, and various propulsion systems. But today I wanted to focus on some of the space science and engineering activities that we're involved in, to include work on spacecraft. We have recently completed, well, last year completed 8 spacecraft that are now on orbit. Science missions, and I'll cover those very briefly. Avionics, mission operations. We have one functioning operations center now, and we're working on another. And a lot of expertise in history in payloads and instrumentation. So just a few missions to highlight. The 4 that are bolded there are either have flown or are currently flying. Those are all, in fact, currently flying. And then one very exciting mission that we are in the planning phases for right now that I'd like to talk about for a few seconds as well. So Cygnus you might have heard about, but Cygnus is a constellation of 8 small spacecraft that are collecting information on tropical cyclones by leveraging signals from GPS. So it's a very innovative technique, a low risk, and it will provide literally life-changing science that will be used in forecasting models to save lives around the world. We also are the PI, Scott Bolton, who I think will be here tomorrow, is our principal investigator for the Juno mission. And Scott is mostly scientist, but he has a very strong artistic streak as well. So it's an incredible program to involve the public in science and exploration of our solar system, because we curate the data and then make it available for people to do artistic works with. And we've seen some very creative art that has come from the science that we've developed for the mission, Juno mission. MMS is a mission to study the phenomena of magnetic reconnection, and it's a constellation of 4 spacecraft that are reconfigurable into different constellation shapes and sizes. We had great success very early on in this mission, and it continues to collect a lot of scientific data, generating the data for many, many different peer-reviewed articles. It's a fantastic mission that has seen success and will continue to collect data for a while. New Horizons is probably one of my favorite because, like Administrator Lightfoot, I also consider Pluto to be a planet, even though technically it's now a dwarf planet. Alan Stern and I have a not-so-secret greeting, which is this, the 9. We like to say there's 9 planets still. The initial reconnaissance of Pluto, Sharon, has been incredible. And in 2019, New Year's Day, if you do not have plans yet, please plan on staying up as the spacecraft makes another spectacular flyby of a Kuiper Belt object that's called 2014 MU69. Now, hopefully we'll be able to get a better name for that before the flyby. And we really don't know what that's going to look like. We used a lot of recent occultation data to try to get a better idea about what 2014 MU69 looks like, but it's a difficult proposition. Lucy is a mission that should launch in 2021. We'll be visiting both L4 and L5, Jupiter's orbit, to visit the Trojan asteroids, another great mission we're looking forward to. Also, we work a lot in space instrumentation, and I don't have the time to go through all the different types of instruments that our scientists and engineers have developed. But the panel today, I think, was talking about what do we need to have a stronger future. And as it's been mentioned, Texas is a key to a successful national program. And what I see is that we really need to coordinate ourselves better in Texas. I would like to see us create more value through collaboration and the change in opportunity. I had to put one equation in, pseudo equation. The change in opportunity is the sum of all the different parts that we have here in Texas. And I really think we can have a big delta opportunity if we work together. By organizing our stakeholders, I can see that we'll be able to enhance and improve the communication amongst all the different resources and assets that we have here in the state, build strong relationships, effectively influence policy and budget decisions, raise the level of awareness about the expertise that resides in the state of Texas, and ultimately help our recruiting. Thank you.
I have a question. And please get ready if you have questions. We've already heard the term aerospace questioned as to whether it has the right scope and covers the right things. And you're from deep sea to the
deep space.
Deep space. Would aerospace in Texas benefit from the adjacent like the energy industry, the healthcare industry? Is there science and commerce in those industries that would bear on aerospace?
I believe so, because ultimately, to do the kind of exploration and research that we all desire for space or for more aeronautical applications, those other questions are significant and important. Obviously, medicine and health, when we do have, I hate to say the word manned anymore, but if we have persons that are part of our exploration program, medicine is a critical element of it, and also energy. We're looking now at the Institute at various techniques for energy storage and energy harvesting. All of those things will be important and critical to success in the future. Any other questions?
Thank you very much.
Thank you.
Now I'd like to invite comments from David LeBron, the president of Rice University. Please.
Thank you. I'd like to just start by thanking all the folks in this room for what they do. I stand in awe of scientists. As an undergraduate, I studied history of science, but I am one of the few people in the room without a Ph.D. That's one of the things that got me to go to Rice, because I was assured that if I was president of Rice, everybody would call me doctor. Which turned out to be true, and that made my mother really very, very happy. I don't think it's a coincidence that this morning was actually reading about imposter syndrome, and that's a little bit what I feel being on this panel. I certainly am not personally a leader in aerospace research, being a lawyer by training, but of course Rice University has been. And whenever the topic of space comes up, I, of course, go back to President Kennedy's speech on September 12, 1962 in Rice Stadium. And the first substantive line of that speech is, "We meet at a college noted for knowledge, in a city noted for progress, in a state noted for strength, and we stand in need of all three, for we meet in an hour of change and challenge, in a decade of hope and fear, in an age of both knowledge and ignorance." And that really reflected a number of things. And Kennedy comes back in that speech a number of times to this idea of a triumvirate or a tripod supporting space exploration and benefiting from it. And that's that triumvirate, which we've already heard about today, of government, industry, and academic institutions providing education and research. And if you look back at the history of what brought the Johnson Space Center here, it was exactly that collaboration. It wasn't only the collaboration that made it a reality and provided what we needed to send men into space, but it was that collaboration that brought together the politics and industry and the capacity both of the academic institutions and industry. Of course, there was no aerospace industry at the time, but there was a very vibrant energy industry. And one of the reasons the Johnson Space Center came to Texas was because that industry provided a basis on which one knew we could draw engineers and technical expertise. And it was all those considerations together that brought it to Texas. So if you look back at that period, and really the period from around 1940 to 1970, what it's characterized by is a belief, among other things, in the capacity of science and the capacity of science to achieve results and for us to organize around that. But what was really interesting, and that grew out in part out of the Manhattan Project and then reflected in the race to the moon, is a belief in fundamental research. And I think if I can turn quickly to the question, we've heard a lot of optimism today, but there are also reasons for pretty serious concern, that if you look at the attitude today toward universities and the attitude toward government support and the attitude toward fundamental research and funding it, those are causes of concern in the environment in which we're operating. And we sometimes forget that it was a belief in fundamental research going sort of parallel with applied research that made us successful in many ways in both the Manhattan Project and in the race to space. So I'm going to run out of time soon. I did want to pretend to say a few things of substance in terms of what we do at Rice. And I think one of the things we see today is the importance, if you take an area like space exploration, the role of universities really entirely across the spectrum, including an area that we heard already about the importance of educating the public and engaging the public. And at Rice, we have the Rice Space Institute, which really carries on that function. We had Fred Hayes come and speak in the fall. It's really important for the public to kind of have a sense of both the history and possibility. And then together with that, we have marvelous research here. I already saw today our Nobel Prize laureate, Bob Curl, is here, who laid the foundations for nanoscience and technology, the chair of our Department of Chemical Engineering, Mike Wong, where we know if we're going to succeed in this mission, it's going to take the fundamental research, changing the materials. Rice has one of the best groups in the planet on materials. And I did want to acknowledge also David Alexander, who really is the person running the Rice Space Institute and maintaining that connection. So if you look across the range, and it's a very full range, and it's actually not just science, because it includes thinking about space policy. And so we have the program on space policy within the Baker Institute for Public Policy. And so you have a full range of conversation and capability, everything from the most fundamental research to apply in space, for example, understanding all the aspects of our solar system and beyond, to applied research, looking at the new materials we're going to need to achieve this, to policy research and understanding. And I think it's important that we engage all of those forms of thinking and research in achieving the results that we seek.
Thank you. Rice has the largest startup business plan competition in the world. I was wondering, I don't know, whether aerospace startups have begun to appear in that system.
That's a good question, and I'll be happy to go back and research it.
Me too. I will too.
I think they have, but it's a great question.
Other questions? Thank you very much. I'd like to move on now to Dr. Ellen Ochoa, who's the director of the NASA Johnson Space Center, has spent 1,000 hours in orbit.
Thank you. Well, I have some slides, so I'll stand up here. And I'll give a little bit of an answer to that question, which is NASA has been involved in the Rice Business Plan competition. But what we've done is kind of look at some of the challenges that we have and then try to match with companies that are out there. And some of the ones that we have that have gotten some of our funding have been in the medical area because of the human health and performance challenges that we have on the way to Mars. So it's been wonderful to be involved with the Rice competition. So I know a lot of you took a tour yesterday of Johnson Space Center, but just in case you're not familiar, we're just across Clear Lake as our main site. We have a little under 3,000 civil servants, about twice that many or a little bit more contractors who either work on site or in the local area around here. And then if you go a few more miles down the road, we have some facilities out at Ellington Field. That's where we keep our aircraft, and we also have training facilities. And then finally, we manage for the agency the White Sands Test Facility in New Mexico. So in Robert's talk, he really explained what we're trying to do with human presence in space, and this graphic just shows it a little bit more. And there's a couple of points that I really wanted to make. First, if you look at the title, the word partnership. And so Johnson Space Center is responsible for a lot of what you see on this chart, but we work in conjunction with other NASA centers, other research centers, academia, many types of commercial partners, small firms to large firms, and of course with international partners. And one of the roles that we have played throughout our history, and certainly are doing today with the International Space Station, is we're sort of the integrating center. We bring in all these partners, we figure out how they're all going to work together so that we can accomplish a joint mission. And that, we believe, is going to continue to be our role. The other thing I wanted to point out is the three regions that you see, which is low Earth orbit, where we operate the International Space Station today, and then the lunar vicinity, and then on to Mars. they really are very different in terms of how we need to operate, as well as just things like the space environment around there. And so that does drive aerospace research and aerospace operations to need to do different things in each of those regions. And maybe one of the things just to point out, for example, is since we deal with human spaceflight, we're always looking at the issue of if we have an emergency and need to get back to Earth, how long does it take and how are we going to carry that out? So in low Earth orbit, you can get back to Earth in a matter of hours in an emergency situation. If you're in the lunar vicinity, it's at best several days. And then, of course, if you're on to Mars, again, at best several months. So if you think about the life support systems you need, things like reliability, maintainability, the ability to have a closed loop system without constant resupply, those things are all very different in those regions. And so as we look to the moon and then on to Mars, you can imagine that there's lots of challenges out there that we do depend on engineers and scientists to help us with. So I wanted to talk just a little bit about each of these regions. I won't talk too much about the International Space Station because the whole next panel is going to be talking about science and engineering on the International Space Station. But I'll just point out we've had, it's been continuously inhabited by astronauts for over 17 years. We generally have 6 people at a time on board, as we do right now with Expedition 54, and 3 of them are NASA astronauts. If you were at the reception last night, you saw a welcome from a couple of them. And they're up there really busy doing research and development, and you'll hear much more about that later this morning. We do have the facilities at Johnson Space Center that really operate and coordinate with mission control centers all around the world to make this happen. There's 5 space agencies representing 15 countries that are the core partnership, but we've actually had partnerships and participation from, I think 98 countries was the last that I heard. I'm sure we're working toward 100 in terms of principal investigators or educational activities. And really we try to coordinate all of that through our mission control here at Johnson Space Center. I mentioned our training facility out near Ellington Field. One of the main things out there is the Neutral Buoyancy Lab, a very large pool that's where we practice our spacewalks that allowed us to assemble the International Space Station and allows us to maintain it today. And we're also supporting actually oil and gas now in terms of kind of cost sharing this facility. On site, we also have our space vehicle mock-up facility, and this is some of the modules, life-size modules of the International Space Station that we use to train in. And we are designated, the International Space Station is designated a national laboratory. So NASA is one customer, but we have many other customers. And they're supported through a partnership with our nonprofit partner, the CASIS, the Center for the Advancement of Science and Space. And this just gives you just a brief introduction to some of the capabilities that we have inside the station. You're going to hear more tomorrow about some of the things that NASA has used the International Space Station for to understand more about exploration. And astronaut Kate Rubin, she's here this morning. She's going to talk to you tomorrow at lunch. She was the one about 1.5 years ago that first sequenced DNA in space and tell you a little bit about why that's important to us for exploration. And then, of course, we have to run all of the logistics for the station, and that does allow us to interact with many different kinds of companies. And of course, we have Orbital ATK and SpaceX that currently take cargo to and from the station, and Sierra Nevada is developing their vehicle. We're also working with 2 companies, SpaceX and Boeing, on developing a commercial crew capability. And we hope to see the first test flights either at the end of this year or into next year for that capability. And then our big project, the one that's going to form one of the cornerstones for moving out beyond low Earth orbit, is the Orion spacecraft. We're responsible for developing that along with our contractor partner, Lockheed Martin. We've had a couple of test flights already. In 2019, we have 2 more test flights planned, one in the spring, one at the end of the year, and they all head toward Exploration Mission 2, which will be a few years after that, which is when you will actually have crew on board and will go beyond the moon. And that's a picture of the current crew module that'll be on the Exploration Mission 1 test flight, which is down at Kennedy Space Center. And I think this is my last chart. So we're envisioning some infrastructure around the moon from which both NASA, international partners, and commercial partners could use this infrastructure to do a variety of activities around and on the moon. And that's one of the things that we're working on right now. So I'm happy to take some questions.
I have a question. So Houston is the energy capital of the world, and it's the healthcare capital of the world, and human spaceflight. Have you noticed any synergies or any advantage that Texas has by having those three
Oh yeah,
together?
absolutely. We feel really fortunate to be in Houston, and there are a variety of different activities that go on in Houston that try to make those connections. There's one activity called Pumps and Pipes that originally started between oil and gas and the medical industry, and then we joined them several years ago. And we do talk about challenges that are similar in terms of the sort of the underlying, either physics or processes going on, how we approach them differently from each of our organizations, but how we may be able to share those solutions. There's also a conference that goes on called Deep Ocean, Deep Space, which is between oil and gas and aerospace. So yes, we try to take advantage of the fact that we live in this amazing city with these incredible industries.
I have a question here.
The present politics, are we continuing to partner with Russia in space exploration?
Yeah, absolutely. We absolutely depend on Russia for the International Space Station. They provide the vehicle that gets our crews to and from the International Space Station at the moment. Obviously, this is a capability we want to have here in the United States, which is why we are working with SpaceX and Boeing. But every single day, we are talking with our counterparts on Russia. And of course, when I showed the picture of the crew, 2 of them were Russian cosmonauts as well. So, we've been very fortunate over the last 20 years or so that even as there have been ups and downs between the relationships of our countries, that we have maintained a very strong partnership through space collaboration. And I think it's actually one of the things that our government actually points to as an example where we can collaborate very well.
Well, Dr. Ochoa will be the moderator of the next panel, so what do you say we move on?
Okay, thank you.
I'd like to invite Louise Proctor forward. She's a planetary geologist interested in icy satellites, but you also are the director of the Lunar and Planetary Institute. Please.
Thank you very much. Thank you very much for inviting me today. So in order to talk about what the Lunar and Planetary Institute does today, I'm going to go back and just give you a little bit of our history. In 1968, NASA was poised to return samples from the lunar surface, and they were trying to think about ways to enable the scientific community to have access to those samples and also other data that was being collected or was planned to be collected by the Apollo program, by the previous reconnaissance programs. And so in 1968, President Lyndon Johnson created the Lunar Science Institute, as it was then called, and it was entirely aimed at providing a base for non-NASA scientists. It was located, I think at that time, on land owned by Rice University, but very close to the Johnson Space Center. And it was encouraging scientists to visit the Manned Spacecraft Center in order to use the labs there, to use the samples, and use lunar photographs. And he actually said this new institute is a center of research designed specifically for the age of space. And I love that phrase because most of us in this room have spent most of our lives, if not all of our lives, in the age of space. And the Lunar Science Institute, as it was, it's now called the Lunar and Planetary Science Institute, has been there all along. At that time, originally the LSI, as it was run by the National Academy of Sciences and Rice University, and about a year later it was taken over by a consortium of universities, of which many of my colleagues are members, called University Space Research Association, and it is still run by the University Space Research Association today. We hosted the first conference where Apollo 11 results were presented to the world. That was 49 years ago. And at that conference, it was recognized that the moon was ancient and it had originally a surface that was molten lava. It was a lunar magma ocean. So it must have been an incredible conference. And since then, we've facilitated and led studies of the moon. We host meetings and conferences, panels, and we develop resources. I'll talk a little bit more about those. After the Apollo program ended, NASA asked the Institute to expand the portfolio to include the rest of the solar system, because there's a lot of other interesting bodies out there. And in 1978, the LSI became the LPI, the Lunar and Planetary Institute. And so we provide an academic atmosphere. We're a focal point. We're a facilitator for planetary science between NASA and the planetary science community, and among the planetary science community, both within the US and worldwide. So here are some of the things we do. Scientific research, fundamental research, underpins everything we do. We have a staff of scientists and postdocs. We're a very small but vibrant center of science in Texas. We have a number of different efforts. We put out publications, a weekly planetary newsletter to the community, a quarterly bulletin. We work with the University of Arizona Press to produce state-of-the-art science textbooks. We do a lot of education and public engagement. We have a summer intern program that is legendary throughout the field, where we bring students from all over the world to the LPI every summer, and we've been doing that for 40 years. We have outreach and education efforts. We run monthly science talks. In fact, I have to miss the dinner tonight because I'm getting back to my institute to host Jonathan Lunine, who some of you know, he's a National Academy of Sciences member. He's speaking on the possibilities of life on Enceladus tonight, unfortunately, so I'm going to miss the dinner. But Jonathan started his career as a summer intern at the LPI a few decades ago. So we have former LPI staff, visiting scientists and interns throughout the planetary community. We have a very long reach. We also have an incredible science library. If you've never visited our building, you're very welcome. The building's always open to the public. We have a lot of resources in the library. We also have a website that has a lot of resources. We host many documents for NASA. And so we're really, as I mentioned, a facilitator. We bridge the gap between NASA and the planetary science community, and we've been doing that for a very long time. I just want to mention also that our lunar support work has been ongoing. We currently work with the Johnson Space Center, particularly the Astromaterials Division, on the Center for Lunar Science and Exploration. And their work includes conducting things like landing site studies, mission simulations, communications trades. We work somewhat with industry and also with other national space agencies. And we also currently are initiating and supporting meetings relevant to human return to the moon. So we held a Back to the Moon workshop in October of last year. Robert Lightfoot mentioned the importance of science in exploration, and we want to make sure that that is included, and that workshop was aimed at that. And we're also supporting a workshop at the end of February on the Deep Space Gateway, so we're still involved in a lot of efforts. So finally, Mae Jemison talked about the importance of inspiration. Well, inspiration features in our mission statement. We are there to advance understanding of the solar system by providing exceptional science, service, and inspiration to the world. And we hope to continue to do that for the next 50 years. Thank you very much.
Texas is very fortunate to have LPI here. What could Texas do better to take advantage of that proximity?
Well, I think Texas already takes advantage. We have very strong collaborations with colleagues at Rice, with the University of Houston and Clear Lake. We do a lot of outreach with local schools and communities and colleges. I think diversity is a huge issue, and it's something that we care very strongly about, and we try and provide opportunities, particularly for the public. One of our engagement efforts is we hold, they're called Skyfest events, where we have an open house or open events for the local community. I think right now we do get a lot of support both locally and from the state. And of course, we're very strong collaborators with Johnson. You know, we have been for 50 years. So I think it's more what we can do for Texas, actually, than what Texas can do for us.
Well, what can you do for Texas?
I hope we're already doing it.
Oh, you just summarized that. Yes.
But if there's any more we can be doing for Texas, I would love to hear about it.
Well, we'll be in touch shortly.
Thank you very much.
Any other questions? Thank you very much. And last, and certainly not least, I'd like to introduce John Sharp, a renowned public administrator here in Texas and Chancellor of the Texas A&M University. Sir.
Thank you. I have determined that the most humbling job in the state of Texas is a chancellor anywhere in the state of Texas, particularly at A&M, because in every single meeting that you go into, you are the least educated person there, and the students couldn't care less who you are, and then they don't know you, and then when they find out who you are, they don't really care if you're not a coach or you're not a professor assigning grades or a slot on the team. A perfect example is a couple of weeks ago, I was late to a meeting with my distinguished professors who I meet with bi-monthly, and I didn't want to be late for those folks, and so I sort of parked in the middle of the street. The only perk you have as chancellor is you have a parking place, a God pass, where you can park anywhere. So I parked in the middle of the street and ran into the meeting, and I came out, and there was a gas leak that occurred in the middle of that meeting, and they had my truck and all of that area roped off, and I couldn't get to it. Was frankly embarrassed to tell the workers who I was, so I just sat there on the side of the Memorial Student Center waiting for the gas leak to be finished, called my secretary, said I'll be late for my appointments. And a student from Brownwood, Texas sat down next to me, and he was just killing time. He said, "What's going on?" He said, I said, "Well, I'm just waiting for my car in the parking lot on the other side. I just don't want to walk around all of this." And he, "Yeah, me too. I'm don't have any classes and everything." And then he looked at my truck and he thought a minute and he said, "How would you like to be the dumbass that parked right there?" And so that's what I get to run into pretty much every day. We at the Texas A&M system see Texas as a leader in aerospace research for a very long time in the future. And since our role, since we have the largest research portfolio of any university in the Southwest, we intend to take a very serious lead. I heard Adam Hamilton say he wasn't sure anybody here, folks here had not heard of the Southwest Research Institute. If you haven't, you've probably just been released from a POW camp somewhere. If they were a university, they would be the second largest research university in the southwestern United States, an amazing institution. But we think we can plant an even bigger flag and bring more aerospace industry to Texas. We have everything we need to succeed. We have the only human spaceflight center in the nation. We have a strong U.S. Air Force presence. We have a large industrial base. Texas currently employs over 148,000 aerospace workers. We export billions of dollars in manufactured aerospace goods. We have over 1,400 aerospace-related companies like Bell Helicopter and others. The Texas research community also has DEP, obviously the Southwest Research Institute, A&M, RISE, the University of Austin at Texas. Just kidding. At A&M, we're all over this area, but we have experts doing some exciting work, and I'd like to talk about a few of those things if I can. Our aerospace engineering obviously is ranked as one of the top in the nation, but there's also other areas of research where our folks are working in aerospace-related fields such as propulsion, combustion, robotics, high-altitude multispectral imaging, mechanical engineering, cybersecurity, biomedical studies, to name a few. Here is a particular interesting example, at least to me, at A&M. Of course, it's a fact that we're a leader in hypersonic and supersonic research. We have a guy named Dr. Rodney Bowersox. Dr. Bowersox is the Aerospace Engineering Department head. He's working on an exciting project with NASA that involves supersonic flight. And so he and Tees are involved in this. The researchers are working on a commercially viable supersonic transport plane. And specifically, Dr. Bowersox and his team are designing an aircraft that can modify its shape in flight to optimize for fuel efficiency or quiet flight. Dr. Bowersox has said that the multidisciplinary project involves advanced aerodynamics, laser sensors, cutting-edge materials to enable a new generation of supersonic aircraft, one that can change shape during flight to reduce sonic bloom and allow it to fly over the entire nation. We already have strength in supersonics and we look forward to advancing that technology. Also, universities like the ones in our system can be a pipeline of talent for the aerospace industry. We're very proud of Dr. Donnie Bunbar, a former astronaut herself. We're building greater capability for increasing the number of humans in space. We have 4 astronauts at A&M now that we're very proud of. Exploration, including Mars and other ventures. You may know that the food for astronauts is processed and packaged on the A&M campus. Dr. Dunbar, I'm particularly proud of her because she's a Chancellor's Research Initiative hire. It's a little fund that we built up and recently replenished of about $150 million for the sole purpose of enticing you to come to Texas A&M. I know that's low class saying this in front of these other folks, but if these guys aren't building you the kind of lab that you need and you're not a happy camper, you just give me a call and, and we have some enticement to bring you folks here. We've increased our National Academy members at A&M by 73% in the last 3 years, and we're very, very proud. There is no higher priority in the Chancellor's office than that right there. So we're also proud of Dr. Dunbar. Our graduate students will have an opportunity to work at JSC. Our students are learning about the biomedical engineering science advancement that will support broader space presence. As another example, Dr. Gregory Chamatoff, who's a professor of engineering practice and a director of ASTRO, which is the Aerospace Technology Research and Operations Center, he's doing exciting work with the spacecraft project, and spacecraft is really cool. It's a new project that came together with the help of NASA and JSC advisors. He describes it as a virtual reality sandbox environment. Spacecraft aims to enable us to figure out how to plan for humans in space because it is designed to allow students, government, and commercial entities to collaborate, design, evaluate, experience the technology of future operations in space. It allows students and other people to virtually visit other planets, pilot other spaceships. If I can just make one comment about what I think we as humans are very, very poor at, and I've noticed this when I was in the legislature, I noticed it when I was Controller of Public Accounts, we are very bad at mimicking nature. If you look at the legislature, they have committees on aerospace, they have committees on engineering, they have committees on the environment. Animals and plants have a different idea about that. It's all the same, it's all together. And we do the same things in our universities all over this country. We have silos where engineering is separated from sciences, or sciences is separated from medicine. And to solve the big human problems, it seems obvious to me, and I think obvious to you, that those entities have to get together. And of course, we all wind up getting jealous of resources, and that's where the Chancellor's jobs come in, is you have to make other resources and incentives to make sure that people come together. An example of what we just started was InMed, where Dr. Pettigrew, Dr. Byington, and Dr. Banks in engineering and medicine are coming together here in Houston with Houston Methodist to produce students who are not only doctors, but they are also masters in engineering. Just think of the weight that you would save on a space flight to Mars if you had your engineer that was also a doctor on that trip. And we're going to do the same thing with veterinary medicine. We're going to start with InVet. I once had the head of the coordinating board came to me and said, we have too many engineers. And I said, I want you to look out that window. 2 people designed everything out there in that window, God and engineers. And unless all of this is going to stop, that's never going to stop. And we think and feel very strongly, and we're going to make sure that the resources are there to bring all of the entities together with resources for all of them to make sure that we produce a very collaborative atmosphere that will make sure first of all, that A&M stays the largest portfolio of research university in the southwestern United States, but also that it does it for the future of what this country is about and what this country needs. I will end by saying I believe strongly in my heart the most important people in the state of Texas are in this room. National Academy members or better. Whether or not the legislature, with this goofy mindset that they have about higher education now, realizes or not, everything good that has happened in mankind has come from a major research university in this country, and I thank God for people like you. Thank you very much.
The governor has asked you to play a role in hurricane response. I wonder if you could comment on that related to the subject of this conference.
Okay. Well, he said the governor has asked me to head up the commission to rebuild Texas from Hurricane Harvey. No, the governor did not ask that question. The governor told me, you're going to be head of hurricane relief. It was a kind of a natural fit because of the land-grant heritage of Texas A&M. When you have any kind of natural disaster in the United States, there is a group of people called Task Force 1 and Task Force 2. Those are people under the direction of the College of Engineering. But they are the people that respond to every disaster that occurs. When you saw on TV folks that were pulling people out of houses and pulling them off of rooftops and things like that, that was all under the direction of Texas A&M's Task Force 1 and Task Force 2. And so those people were there. The Texas A&M Forest Service does that same search and rescue, high water rescue, and all of those kinds of things as well. What was missing from that is the response side of that. And how do you coordinate all of the county judges who are in charge of disasters and mayors who are by law the people who can make decisions about whether or not you spray mosquitoes over my area and all this kind of stuff. We can't do anything without those folks. And A&M happened to be the only place that had the network to do that because we have an office in 252 of the 254 counties in the state of Texas through either A&M Extension or experiment stations and things like that. We took those people and said, your part-time job for the next year is to be right at the side of that county judge, whether it's Sylvester Turner or whether it's Ed Emmett or whether it's the judge in Refugio County, and solve that person's problems no matter what they are. And so things like filling out paperwork, if you're the county judge in Houston, you know a hell of a lot about disasters. I mean, Ed Emmett has got his stuff together better than anybody I've ever seen. But when you're the county judge in Refugio and you've never been through a disaster before, you don't know what FEMA is, much less how to fill out the paperwork. And if you don't know how to fill out the paperwork, 5 years from now, you got a rude awakening because there will be an audit coming by the federal government and they'll claw that money back out of your budget. And so Kathy Banks sent 50 or so people that she had trained to those smaller rural counties to help them fill out the paperwork and make sure that it was seamless. And I think that's one of the reasons that this has been, aside from the federal government not wanting to appropriate money for disasters all of a sudden and things like that, from a state point of view, the governor's response, I think, has been really good. But much of the credit goes to the field personnel that are out that kind of second half of what Texas A&M is about, helped them.
Can I ask you another, there is a question there, but let me ask one more. These folks, you just, the mayors and the judges and what was that word you used to describe the legislature? Was it?
I can't remember.
It was like nuts or
no,
crazy
I didn't
or something like that.
I'm sure I didn't say nuts.
You didn't say, oh, I said that.
You said that.
Yeah. What can the people in this room do to enhance the prospects for research advancement in the state of Texas among those people?
Make sure folks know what you do. One of the things that I found when I first came to A&M is lots of really smart people that were doing amazing stuff, and I would go to them and say, why haven't I read about this stuff? My God, the legislature would love to hear about it. And they would go, I don't care if they know about it. I care if I know about it. I'm doing this work. And that's all fine and good. But get your work to your press person and get it out there and let the public read it on the front page of the paper. If the public knew what I knew about a public university, they would shoot the first legislator that stood up and challenged funding for higher education in the state of Texas, particularly for research in higher education. And so make sure everybody knows it. Don't keep it a secret. We're doing our best, but you know, every now and then, my favorite story is I had this professor I was having lunch with, and he said, I've just invented, I'm really excited, I just invented this thing. My friend's daughter got burned in a house fire. And so I wanted to make some pajamas that didn't burn. And I went, okay. So he invented this fluid that you can treat with the pajamas and throw them in a fire, they don't burn. I said, that's good. I said, are you done with that? And he said, yep, done with that, got the pajamas and everything. And I said, do you think some home builders might be interested in this? Like spray this on wood and houses don't burn down, and some aircraft carriers. And so we put him with American Airlines and some folks like that. And so the seats on many airplanes now, you know, as they're new, are being treated with this. But he was, in his mind, satisfied that, by God, look what I've done. I feel good about what I've done, but you've got to take it to that next step. You've got to take it to somebody that's going to commercialize this, let the world know about it, and let the taxpayers who are going to be paying for this stuff read about it. We do amazing stuff. 1,000 years from now, when the aliens come here, or the ants, or whoever's in control by then, comes here and reads the history of the United States of America, their conclusion will be that the greatest institution that they ever produced was democracy and great research universities. That's what their conclusion was going to be. And all you got to do is think about that. Why is China here trying to, you know, replicate everything that we do? Why is everyone else here? Why are these kids coming here? Because we have the greatest university system that exists on planet Earth, and we can't let that slip away.
Thank you.
Thank you.
Gig'em. In closing, let me ask the panel, what topic related to aerospace research should we have addressed that we didn't? What did we leave out? Is anyone sitting there annoyed about some particular topic that we didn't touch on? I know I sprung that question on you. Come on now. All right, more money.
I didn't hear the question.
The question was, what did we forget to talk about in this 50-minute panel that we should have?
You know, I would say we've talked about Mars, but we haven't talked about public willingness to sustain a commitment over a long period of time and how you get that sustainability. We think about Kennedy's challenge to go to the moon and return someone. I'm thinking about the superconducting super collider that didn't superconduct, did implode. How do we, with such bold ambition, with multiple presidents, legislatures, and so forth, sustain a commitment?
Well, we heard an answer to that a few seconds ago, more communication about the consequences of research. So communicate. What we have here is a failure to communicate. Yep.
I guess what I would say is what we've tried to do more recently at NASA is kind of take a step above what we normally talk about. We kind of come out and talk, here's what we're doing, here's where we want to go. We've tried to talk more about what is the value that we bring to the nation as a national space program. And of course, there's a variety of things, including global leadership, including national security, expanding scientific benefits, which is really what we're focused on this conference today. And then, of course, there's that big piece of inspiration, which in the end, I actually think is the absolute most important one, because it really motivates people to do things in a variety of fields that they never would have thought of. But that's one way that we are trying to talk about it in order to see if that helps in that sustaining support.
Yeah, people of my age think that NASA produced Tang and Velcro, and we're really grateful. You must be talking about, I know you didn't, but we think that. So I guess what I heard you say is to better communicate the non-Tang, non-Velcro consequences of the research in aerospace. So So with that, thank you very much for joining us today. Please join me in thanking the panel.
Nice to see you, David.
Thank you very much, Dr. Metcalfe. I just want to do a real quick synopsis of what I heard. I heard that we're connected here in Texas across the state with all areas of aerospace and research. And that not only that, we do basic research, we do operations, we do applications of space sciences to life here on Earth. That we look at weather on this planet and on other planets, and that we look at all the life sciences, health, medicine, and agriculture, and that there is even a healthy competition among universities and researchers, and some are willing to ease the way to have people move from one place to another. That's what I heard. But there are incredible resources that we connect to deep ocean, deep space, and that the final thing is that there is an inspiration in a mission statement, which is incredible, so that we know that. And then finally, what I heard is don't keep this a secret. So it's not keeping it a secret not only to about the work that individuals do, but all the things that are available in Texas. Thank you all so much for sharing that with us. Thank you, Dr. Metcalfe. There will be a short break, and we ask everyone to reconvene here at 10:20 a.m. 10:20 a.m. Thank you.